Trigger Independence Day. Yes. We can build nuclear weapons.
Okay. Whew. Now, there's 4 topics I want to get through. So these are the 4 topics that are left on mechanics, and then the mechanics is finished, and then you have the test on Friday, and then after Friday next week we start a new section, the electricity. Okay, so what we're going to have a look at today, firstly, circular motion. Can I leave the light on? You can see okay? Yeah? Okay. And where's Fahid? Was he in earlier? No, okay. So far we've looked at 2 types of motion. We've looked at motion in a straight line, and we've looked at motion in 2 dimensions, which we called the projectiles. But in fact, this 2-dimension motion, we can think of it still as 1 dimension. So this is 1 dimension, this is 2 dimension, but it's really 1 dimension plus 1 dimension. We have the x and we have the y. So far we looked at linear. What we're going to look at now is some special type of motion called circular, which, as the name suggests, it is just motion in a circle. So you have something traveling around in a circle. An important type of motion, a very common motion in nature, you think about the electron, or the sun, or the earth, it all looks like this. So some people have seen this before. So what causes this to move in a circle? What's the cause that makes this move in a circle? Any ideas? Like, why does this move in a circle? Any ideas? Force?
Yeah, it's a force.
A special type of force. What's special about it? Who? Well, is the force like this? Perpendicular. Yeah, no, you see, you don't need to give me fancy words. Just keep it simple. Keep it simple, if you know. So the force, which way? Is the force like this?
Yeah.
Oh, no, you see, you're complicating it.
Another way.
Huh? Yes, which way?
Towards the...
Yes?
Towards the
center, yes, yeah. So what's happening is there's a force, and the force always points towards the center here in the circle. Compare this to when it's moving in a straight line, the force points in a straight line. But if the force changes, then you can make it go in a circle. So this kind of gives us our first definition. So we can say yeah, there's a lot here. Okay, so when a mass, I don't know how to put this, yeah, when a mass moves at a constant speed in a circle, it is because a force is acting on the mass directed towards the center of the circle. And, now it's a big definition, I'm sorry, and perpendicular to the velocity of the mass. So I'll give you a minute to write all of that down, that big definition. You got that taken down? So notice how I said perpendicular to the velocity. What I didn't show you on the picture yet here is that here's the velocity here, and here's the velocity here, and here's the velocity here, and they're always perpendicular to the force in this motion. Okay. Unfortunately, you do need to know all of this for the exam, because in the exam they sometimes say explain circular motion or explain how it's travelling in a circle, and this is the explanation. So I'm sorry, you're going to have to remember that as best you can. Now look, for the exam, I don't worry so much. Don't think I walk around with this remembered in my head. All I'm really doing is I understand what it is and I just try to put it in words. So if you open up 10 different physics books, they'll have 10 different explanations. They'll just look very similar to this, okay? You know, I said when a mass moves. I could have said when a mass travels. You know, I mean, don't think you need to remember this word for word. Just understand what I'm saying. What I'm saying is, this is traveling in a circle because the force points to the center.
Actually, the center is mass or
Oh, sorry, see, I wasn't clear. The center of the circle, and the mass is around the circle, yeah. So you're right, I should be clearer. When a mass moves at a constant speed in the circle, it's because the force acting on the mass directed toward the center of the circle, and the mass is here, and this is the center of the circle. So the first thing is you understand what I'm saying, then you try to learn how to explain it yourself. Okay. Okay. Okay, do you have that taken down? Yeah? Okay. Now, before I go on to talking about the circle a bit more, I just need to talk a little bit about angles here. So I know we're all very familiar with using degrees. Well, yeah, it should be 360 degrees for one circle. But we don't really use degrees. We use a different unit called radians, yeah. And this is degrees. And radians are much bigger than degrees. It's about 6.2830 radians in one circle. Now, I can write it exactly, but just for the moment I'm just saying it like that. Now you might say, why not use degrees? Why use these radians? Degrees are easier. And the reason for that is the formulas I'm going to show you, they only work if you use radians. The formulas don't work if you use degrees. So you have to use radians. In fact, if I want to be precise, it's 2 pi is the number here. Okay, so if you want to go from degrees to radians, if you want to convert, the way you convert is you multiply your number by pi over 180. And if you want to go from radians to degrees, you multiply by 180 over pi. So I'll just do one little example for you. Do you have your calculators? So first example, 30 degrees. Well, you tell me. Tell me what that is in radians. Ah no, let's make it ugly. 32 degrees. Okay. So what did you get? Did you get it?
1 over 6.
Yeah, what is it?
1 over
1 over, give me as a decimal.
6.
0 point? Exactly?
Yeah, 0.558.
Yeah, 558. Yep, okay. So this is the same as 0.558 radians. Yeah. Let's have a look.
So I can't use it won't be.
I think you just typed it in. It's 32.
Minus?
No, if you want radians, you multiply pi.
Okay, yes, I already.
You got it?
Yeah, I got it.
Now wait, they give you the answer nicely as a fraction here, but if I just hit this button here, I can get it as a decimal.
Thank you.
Yeah. They never ask you to do this in the exam, but they could. Okay.
What's the change from decimals to degrees radians?
I mean, it says it on the syllabus, they never ask you to do it. Okay. Alright, now that we have radians covered, I think I can have a look at the formulas. So that angle there, I call it theta, okay? And there's a force here, F, and of course there's a force here, F. And let's not forget there's a speed, a velocity here, a V, and of course it's the same velocity here, V. I'll give you the formulas now for finding, oh yeah, and one other thing here. There's a distance which I'll call, wait, get a different colour here, S. And S, it's the distance on the circle which is, we have a word in English for that called the arc length. So that means the distance on the circle. Now you remember from linear motion, you have equations for u, v, a, t, and s. And likewise for circular motion, you have similar equations. I won't do the proof. Proof is a little bit too difficult for us right now, so I'll just give you the formulas. The first formula, oh yeah, and before I give it to you, I'll just say again, these formulas only work if you use radians, not degrees. Use radians. So the first formula is S, oh yeah, forgot. Also, we'll say it's radius or. Okay. F equals or theta. That's the first formula. So if you want to know the distance here, you need to know the angle and the radius. Okay? So that's the first formula. Now, before I give you the next formula, can I just go back a moment to my picture at the start? I'll zoom in. You see when this is moving in a circle, it has a speed, you know, like for example 2 meters per second. 2 meters per second, or whatever the speed is, for example. But of course, if you look at the angle, look here. Here's an angle, and then here's a different angle, and then here's a bigger angle. So the angle is changing as it moves around in the circle. Yeah? So we think about something like okay, hang on. Now, English time. Whoops. So I don't want the native speaker to say anything yet, okay? So angle is the noun. So what do you think the adjective is? Huh? No? So angle. You know angle? Is a noun, okay? Did you?
Yeah.
Alright, don't say anything. If angle is the noun, what's the adjective of angle? Do you remember? Angular. So this angle is changing, so we say it has an angular speed, angular velocity, angular speed. So, you know, for example, here the angle is 0, and then let's say 1 second later the angle is 1 radian, and then 1 second later again the angle is 2 radians, and then 1 second later again it's 3 radians. So what's happening each second? The angle is increasing by 1 radian. So we say its angular speed is 1 radian per second. Okay. So we have a term now, a new term. So I'll just put on the side here, and we call angular speed. That equals omega. That equals the change in the angle divided by the time. Or in other words, it's the change in angle per unit time. So then the units are radians per second. Can you see how it's similar to speed? Because speed is distance per second. So angular speed is angle per second. Yeah. Okay, so if I go back here, that's our second formula. That omega is the change in the angle, that's messy. The change in the angle divided by the time. Okay. Now the reason I need to tell you this is for the next formula. The next formula lets you find the V. You can say that the V is equal to the omega multiply the radius. So that's all. So what's good about this formula, which is very, very common, is you know the V and you know the OR, so then you can get the omega. So think about a car. A car that's driving in a circle. You know a roundabout? Do you know this word, roundabout? Yeah. So the car goes around. So we could work out the omega, sorry, I haven't said that word yet. We can work out the angular speed from this formula, V divided by R. Angular speed is V divided by R. So think about a car. What would you say its speed would be if it's driving around a big roundabout? How many meters per second? Maybe 20. And what about the radius? How big is the roundabout? What do you think? I think we could figure than that. Yeah, well I guess it depends where you are. I'd say, well that's a big roundabout, yeah. At least about 4 meters. Whatever. So you could have 20 divided by 4, so what's the angular speed here? It would be 5. So you're saying that the car changes its angle 5 radians per second is the change in the angle. So this is the most common use of this formula, is to calculate the angular speed. Now you heard me use a different word for angular speed. What did I say? Omega. And that's because that letter is not W. It's a Greek letter. You know Greek alphabet? Alpha, beta, gamma. So this one here, I'll sometimes call it omega. Because it's a Greek letter. It's not an English letter. I know it looks like a W, but it's not a W.
It's more circular.
Yeah, it's more circular.
Yeah.
You know your Greek letters, don't you? Alpha, beta, gamma, delta.
Oh.
I know alphabet.
Delta.
Delta.
Epsilon.
Epsilon.
Not.
Sigma, yeah.
Sigma.
Zeta. What did I say?
Zeta.
What was these?
Lambda. Mu.
Mu.
Iota. Phi. Psi.
Theta.
Theta. Omega.
Better than omega.
What else do you know?
A little more. I just can't remember.
Kappa.
Alpha.
Eta. No? You don't learn these in school? I promise you, when you finish your engineering degree, you'll know all of them, because all of them get used. Okay? Each one of those will be used.
So actually now the W is what's the plan?
Well, no, it's
What's the name of the W?
Yeah, this is called omega.
Omega.
A different formula, which is like, they use alpha and beta in a different formula. Mu is equation.
Yeah. Lambda for wavelength.
Sigma for zone. Like all of them have different uses.
They're all used.
Yeah.
Yeah.
The capital relationship.
Yeah, and then there's capitals as well. Capital Sigma, capital Lambda, capital Omega.
Yeah.
They're used as well.
Yeah.
Okay, so we have this formula. Now the next two formulas are really, the next one is really, really important, because the next one is for the force. So you get F equals m omega squared or. But sometimes it's convenient not to have omega. You can replace the omega, you can say omega is V over R, so you could put that in here to make a new formula.
X equals mv squared.
Yeah, mv squared over R. So you have a choice here.
That was which was different.
It completely depends on the question. Okay. So this is how you can calculate the force. So I think there are two more formulas I want to show you. So the next one is you would like to know the time to go around once. Okay. Does anyone know the name of this time? The time to do one
Period.
period. Yeah. So we say the periodic time. Period is the noun. Periodic is the adjective. So, well, have a guess at what letter I use for this. T. Yes. So T equals 2 pi over omega. That's the periodic time, the time for one period, for one cycle. So, you know, you use this formula if the question says, how long for the car to drive around the roundabout? You know, something like this. There's one more formula I want to show you. And it's for small f, which we haven't really talked about yet, but it's called frequency. Do you know this word in English, frequency? Yeah? Louise, do you know this word, frequency? In English?
Average.
Huh?
Average.
Yeah, but just normal English, would you use this word frequency? How would you use it?
How many times?
Yeah, but I just didn't.
Yeah, talk to your EAP teacher. How much you use this word?
I'm gonna use that in the maths exam.
Yeah. Talking to Stephen B. How would you say it to him? How could you use frequency? You know, you could say things like how many times you practice English at home, how many questions, how many times you practice your presentation. Like frequency means how many times, how often. Yeah. So when I talk about frequency for a circle, it's how many times I go around the circle in 1 second. In 1 second. Okay? Now, we don't have to just use it for circles. So if you look up here and look at my pen. So, you see how I'm hitting twice per second, 2 times per second. So I say the frequency is 2. And then, you know, frequency is 3 maybe. So frequency tells me how many cycles, beats, how many times it repeats in 1 second. Okay? So if you think about the car, or the bus or whatever, yeah? So if you think about a car going around a roundabout, what do you think the frequency is? What would you say? Because if you say 5, it means it goes around 5 times in 1 second, which is way too big. Yeah, maybe go ahead.
0.3.
Maybe 0.3. It means it only does 0.3 of the circle in 1 second. So look, if the frequency is more than 1, it means you can do more than 1 in a second. But if the frequency is less than 1, for example, if the frequency is 0.5, listen, this is 0.5. It means I can only do half per second. It takes me 2 seconds to do 1. Okay? And this would be 0.25. You see, it'll take me 4 seconds to complete 1. So anyway, that's frequency. How do we calculate frequency? It's really, really easy. The formula is just this, 1 over T. So you can see what the unit is for frequency. What's the unit for frequency? From this formula, what's the unit for frequency? Yeah, the unit is per second. And there's a word in English which we use when we talk about per second. Does anyone know it? A different word for per second, for this unit per second. No? Hertz. You know this one, don't you? Hertz. I tell you where maybe you've seen this before, on a television. So the television, you know, when you go to the shop, it might have a sticker on it, and the sticker might say, for example, 100 hertz. That means 100 per second. What per second? 100 pictures per second. You know, that's what it would mean, that the picture changes 100 times per second. And so 100 hertz. Where else might you see hertz on things? Well, I know there's other stuff too, but I just want to keep it simple. Yeah, but I want to keep it simple. No, I think the TV was the simplest example that I knew. So hertz, anyways, it means per second, and it's for frequency. Okay. No, seconds. Yeah, like normal. Yeah. Yeah. Now you see here, this is radians per second. So this 2 pi up here is actually 2 pi radians. I didn't write radians in here, but you see the radians cancel, leaving me with only seconds there. So that 2 pi is really 2 pi radians. It's a heavy unit. Right. So you can see that there are 1, 2, 3, 4, 5, 6, 7 formulas there. But the good news is they're all in the formula book anyway. So what we're going to do now is we'll look at some examples. Okay. So make sure you have these. Oh, and by the way, not that it's a new formula, but you can still use F equals MA as well for these problems, which is important. Okay.
Where do you use I?
I? No.
I think I remember some inertia.
Yes, inertia I. No, we don't do that. I know what you're talking about, yeah. Okay. Yeah, let's have a look at an example. Can I go down? Okay. Right, so what I'll do, we'll draw a car and it's travelling around in a circle. So let me see, what will I tell you about the car? I'll tell you the mass. Say it's 1,500 kilograms. I'll give you its speed. It's 24.5 meters per second. I'll give you the radius. The radius is, let's say, 5 meters. So my question then is, first question, what is the force? And just to make it clear, it's the force that makes it go in a circle, so I'll just write it like that. And number 2, I want to get the time here for one cycle. You know, I think I'll let you try to do this first. So I want you to use your formulas I gave you to get me the force and the T. Yes, I think that'll be good if I let you do this first. So try to get for me the force and the time. Don't worry, I'm not leaving you. I'll be back in a moment, and then we'll have a look at the answer.
Oh, it's just periodic time. Consumption is what I guess to do.
So I use the P equal to pi over omega 6 alpha the time. T. So how can I get the omega?
Use V over R. There's V equals omega R. So you just use that one and switch it around, so it's omega equals V over R.
Do you know the proof for the problems?
I used,
You know the proof?
I used to, I can't remember.
Some of them just...
They're very hard. They're very hard, yeah. I know for S it's fine. For omega it's fine. Omega it's fine. For T is fine as well. V and F. That's the thing. For V and F. Like, cause for V to show that. It's not hard, but those are just a bit. They're not necessarily like impossible. Like if you learned it, it would take you about like an hour or so to really understand this properly. Like it makes sense. It makes sense, but like it's just you won't understand it, but like to actually be able to, if someone asks you to do it, to be able to do it, it'll take you like a while to get that, like thing.
Just because
Well, V. Or F.
Got the answer?
This is the MA. The MA helps them shoot.
You got the answer? Did you all have the same answer?
Yeah.
Oh yeah? Oh good. So, what formula did you use?
For F.
Yeah.
V squared.
Yeah, and V squared over R, because this is the V, this is the M, and this is the R, and what did you get?
1800. 75.
Like this?
Yeah.
Newtons. So that's how much force is going towards the center of the circle. Now this one's just a little bit trickier. This is 2 pi over omega. But omega is V over R. So you don't know the omega. So if you put the numbers in, what did you get here?
1.28.
1.28 seconds? Okay. Yeah, not so bad. So let's look at a more difficult one now. By the way, there's another adjective I want to give you, but maybe someone can tell me. So, this force here, how would you describe this force? What adjective would you put onto the word force? So, you don't say it's a circle force, because circle is a noun, really. So what would you say? Yeah, you see, you think it should be circular force, but the problem is circular force makes it sound like the force is in a circle or something, you know. So, sorry, it's not circular force. Nice try, though. Huh? Do you know it?
It's not argue.
What did you say?
Okay.
No. Nice try, though. No, you take the you got it, yeah. So the adjective here is centrifugal, really good. Yeah, how did you know this?
Because you said you mentioned the syntax.
Still quite good.
Your English is quite good. Very good. You're right, very good. Centripetal force. Don't worry, that word is in the question. So if you see centripetal force, it just means the force here. There's circular force, if you want. Okay. Now, I'm going to do another example here. This one's a bit more difficult. So I'll do it for you. So what you got here this is 3 kilogram ball, and it's being spun around in a circle, and I'll make it easy. I'll say that it's a 1 meter string. And the speed we'll say is 5 meters per second. Why did I have? Okay, so just so you're clear what's happening here, I'm spinning it around like this in front of me, okay? So it's like I'm standing here and I'm spinning this around, so the ball is going around like this. Well, I haven't gone the other way, going around like this, okay? Now, did I tell you the word tension before? I can't remember. Do you know what tension is? Yeah. I would have done that, wouldn't I? Anyway, just to remind you, tension is a force like in a string, like here. So, you can do it like this, yeah. So I'm just spinning this around, like that. Tension, you know, if you pull something, the force in the string, that's called tension. I'll write that on the board. So if I'm turning this around, there's a tension in the string, okay? And what do you think? If I go fast, is there more or less tension? More. And then if I go slow, it's less tension. So tension is in the string here, so I'll draw it. So there's a tension, and there's tension, and then there's tension, and there's tension. Not quite. Kinda. Not quite. Do you think those tensions are the same or different? What do you think? They're different? Yes, because of gravity. Yeah. So my question now is, where is the biggest tension? The top, the bottom, the left, or the right? Bottom is the biggest tension. Yes. And where's the smallest tension? At the top. this is not all the forces. As you said, there's also gravity. So there's a force here, mg, 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 and mg. Now for this question, I want to know what is the biggest and what is the smallest tension. I don't care about the left or the right. Okay, I don't care about the left or the right. So I'll just go down. Can I go down? Yes? Yeah. So at the bottom, I have an mg and the t. And then at the top, I have an mg and the t as well. At the top, the total force is T plus mg because they add together. But at the bottom, the total force is T minus mg because they are in opposite directions. Yeah?
So it's still?
No, yes. And what about the F? The F is 0, not 0, the same, different. What do you think about this F? No, not 0. Sorry, Kevin. The F is not 0. And in fact, the F can't be 0 because it is this F that is making it go in a circle. When the tension and the mg go together, they make an F. And this F is the F for it going in a circle. So it's not 0 and not changing. It stays the same. So look at the two formulas. The F is the same, but the T's are different. So what I'll do is I'll just call the one at the bottom T1 and this one here T2 because they're different tensions. Alright. Now, let's start with the bottom, this one here. So I'll just scroll down a little bit. What formula should I use for F? You have two formulas, you have three formulas for F. F equals ma, F equals m omega squared or, F equals mb squared over or. Which do you think I should use for this question? Nope. At least not yet. Why? I gave you the V, didn't I? And did I give you the N?
Yeah.
Did I give you the O? Yeah, so you can get F equals mb squared over or. So can you take out your calculator and tell me what this number is? What did I say? It was 5? So in total it's 50? 15 newtons. No?
75.
Something went wrong for you, Abraham.
You didn't square the club.
Is that the square? Yep. So, therefore, 75 equals T1 minus mg. So, tell me the T1, please. So T1 equals 100 and...
24.
Yeah.
105.
Yeah. Yeah. Now let's get to T2. In fact, it's exactly the same. For T2 we have 75 equals T2 plus mg. So then what's the T2 here?
$25.95.
What does it say?
25.95
newtons. Okay. Right. I don't want to do too many examples because I would like you to try to do some yourself without seeing how to do it. If you try to, maybe you can figure it out. Yes. I think I'll just do those examples, but if you can't do it, we'll look at it in the next class. Now, it looks like there's 6 questions, but there's only 5, because in fact here in question 4, it's not a question 4. The diagram is part of this question, so there is no question 4. Okay, they go together. So there's 5 questions. Now let me see the time here. Yes. I think I'll give you a few minutes to practice some of these, and then we'll go on to the next topic then. Okay. The first one is, number 1 is exactly different numbers, but the same as what I just did. And number 2 is similar to the car. Number 3 is something different. We'll see if you can do it. So I'm trying to do these now for a few minutes. Was Saeed in earlier today? No, so you haven't seen him all day?
Yeah.